Good day, we are Group SSWS, and in this video, we'll be presenting our project titled Smart Student Wellness System. Without further ado, we will start with the introduction of the system. The Smart Student Wellness System is a web-based platform developed to support student wellness services in the School of Computer Science in USM. This system allows students to complete a wellness assessment questionnaire, and based on the answers submitted by the student, the system will process the result and identify the student wellness concern. The system also helps determine their student risk level and their suitable support unit that should handle the case. Overall, this system helps make the student wellness support process more organized and easier to manage. The purpose of this system is to provide a centralized platform for student wellness support. Through this system, students can answer a wellness questionnaire, and the system will process their answer to detect their wellness category and risk level. The system also supports automatic case routing. This means the student case will be assigned to the suitable support unit, such as the counselor, academic advisor, or CS society. The scope of this system includes all starting from user registration and login, questionnaire submission, to the case status and remarks update. The Smart Student Wellness System consists of three main modules. The first module is the User Management module. Its function to manage user registration, login, logout, and role-based access. This module ensures that student and support units member can securely access the system according to their assigned roles. The second module is the Wellness Assessment module. This module enables students to complete the Wellness Assessment questionnaire. Once the questionnaire is submitted, the system calculates the assessment score, identifies the wellness concern category, determines the risk level, and recommends the appropriate support unit for further assistance. The third module is the Case Management module. This module handles the management of student wellness cases. It allows support units to view assigned cases, monitor case progress, update case status, and record remarks or follow-up actions for each student. These modules work together to support the overall wellness assessment and case management process within the system.
Now, I will explain about the black box testing. Black box testing validates system behavior based on the specified inputs and expected outputs without any knowledge of the internal code structure. For our system, we applied 4 techniques, including the boundary value analysis, to test the values at the extreme edges of valid and invalid input ranges. Then, equivalence partitioning to group inputs into classes and pick the representative values from each. Next, decision table to cover the combinations of the conditions and their resulting system actions. And lastly is the use case testing to derive the test cases directly from the real user journeys. So, each technique was chosen based on the nature of the feature being tested. Here are the features mapped to each technique. For boundary value analysis, we tested 3 features, including the questionnaire score calculation, which processes submitted answers and computes a total score, and execute routing logic and assign case and routing, which route and assign cases based on the score thresholds. BVA was suitable here because these features rely heavily on the numeric score ranges with clear minimum and maximum boundaries. For test identification, here is how we apply boundary value analysis. For questionnaire score calculation, the valid score range is 0 to 55. Number lines diagrams on the right show the boundary points visually, including the invalid, valid, and boundary crossing values. For equivalence partitioning, we tested view over questionnaire results, which displays the total score and category breakdowns. EP was used here because the system needs to handle different classes of score data, including valid scores, missing data, and out-of-range values. Here is how we define the 7 equivalence classes. For valid values, it includes the total score within the range, which is 0 to 55, where the representative value is 28. Another valid values are minimum score, which is 0, and maximum score, which is 55. And lastly, the complete category breakdown available means that all 3 subscores are present. Then, for invalid values, first is when there is no questionnaire submitted, so there is no result to display. Then, when there is partial or missing subscore, means the student not answering one or more category scores, which result to null values. And lastly, when there is invalid score data, such as -1 or value above 55. So here the representative value is -1. So, by testing one representative from each class, we can efficiently cover all meaningful input scenario. For decision table, we tested 7 features, including registration account, login, view role-based dashboard, category detected, case risk level, support unit assignment, and filtered assessment records. Decision table was chosen because these features involve multiple conditions that combine in different ways to produce distinct outcomes. Here is our decision table for login feature, where we identify 3 conditions: whether the email used a valid USM domain, or whether the email is registered in the system, or whether the password is correct. Hence, this produced 5 rules. Rule 1, all true, so login successful. Rule 2, valid domain and registered email but wrong password, so system shows wrong password error. Rule 3, valid domain and correct password but not registered email, so system shows invalid credentials error. Rule 4, valid domain but not registered email and a wrong password, so system also shows the same error, which is invalid credential. And lastly, all invalid, so system will show invalid email domain error regardless of other conditions. So this table ensures that we test a very meaningful combination of conditions. For use case testing, we tested 5 features, including terminate session, submit question and answer, view assessment history, manage and view case records, and update case status and remarks. These features represent the end-to-end user workflows, and use case testing was the most appropriate technique because each feature followed a realistic user journey from the precondition to the normal flow, alternative flow, and also the exception handling. For use case testing, I will explain the terminate session feature. The actor is an authenticated user. In the normal workflow, the user clicks logout button and the system will invalidate the session and redirect to the home page. In the alternative flow, if the user closed the browser without logging out, the session auto-expired after timeout period. Then, the post condition will confirm the session is fully terminated and all protected pages become inaccessible. Lastly, in the exceptional flow, if a network error occurs during the logout, the error message will show and then the session remain active until the timeout.
For our testing, we use whiteboard testing. This means we look inside the actual code, not just the inputs and outputs. We check every line, every decision, and every path in the wellness logic. We use 3 types of coverage. First, statement coverage. Every line of code runs at least once. Second, branch coverage. Every decision is tested both way, true and false. And lastly, path coverage. Every possible path through the function is tested. This table shows the features we tested and which coverage type we use for each one. The first 3, manage questionnaire, submit answer, and manage case record, were tested with statement coverage. The next 2, score calculation and view risk level, used for branch coverage because they have if-else decision. And the last 2, which are routine logic and assign case, used for path coverage since we needed to test every full path through them. Now, let's look at the transfer path for update status. This is one of our statement coverage tests. The first path is ABC. The input is a case that has already been resolved. The system follows this path. As you can see, I highlighted and written the error message already resolved, can update. It is block path. The second path is ADE. Here the case is not yet resolved, so the system is allowed to update it. It follows this path and saves the new data into the database. So the 2 paths cover both outcomes, when an update is blocked and when it succeeds. Next is decide risk, one of our branch coverage tests. This function decides the risk level, high, medium, or low based on the category and the score. The first path is AB. The category is mental health and the score is 5, which is below 8. So the result is high risk. For the path AEG, the category is academic stress with a score in the middle range, so the result is medium risk. Lastly, for this path is AEIL. The category is social isolation with a low score, and the result is low risk. As you can see, each test case enters the same function but follow a different path to a different result. The decision table on the right shows the true and false value for every condition all along the way. Finally, decide category, one of our path coverage tests. This function decides the student category and which support unit they go to. For this control flow graph, the first path is ABC. The mental health score is 10, which is below 13, so the category is mental health and the student is rotated to the school counselor. The last path is GHI. Here the mental score is 13 and the social score is higher than the academic score. So the category is social isolation and the student is rotated to the CS society. Each path sends the student to a different support unit. Together, this path test the complete routine logic from the start to finish.
This slide summarizes the recorded whiteboard test demonstration showing several representative test cases for main system function, the sample input value used, the expected output, and the observed result. Where all displayed cases passed successfully and the full test run also shows that all 19 unit tests passed. For this demonstration, the tests are divided into two parts. The first part focuses on wellness logic, which includes score calculation, category classification, risk level determination, and end-to-end scoring workflow. The second part focuses on workflow and system management logic, which includes assigning correct support user, updating case status, and checking authorization for question management. All of these tests were written as unit tests using PHP unit to validate the system logic and business rules. The first test file verifies whether the system can correctly process a student wellness question and responses and transform them into meaningful outputs such as category and risk level. The tests are grouped into 4 sections, which are test for score calculation, test for category decision, for risk classification, and complete end-to-end workflow from input answer into final risk output. So the first group of tests is the calculate score function. This function is responsible for summing student answers into 3 wellness categories, which are academic stress, mental health issue, or social isolation. For the first test, sample scores are inserted across academic, mental, and social questions. For example, values such as 3 and 4 for academic, 5 and 2 for mental, and 6 and 1 for social. The expected result is that the system correctly adds the score within each category and also produces the total score. The next group of tests is the decide category function. This function determines the student's main wellness category based on academic, mental, and social score. The system can classify a student into one of the 3 categories, which are mental health or academic stress or social isolation. For the first category test, the inserted input uses a mental score below 13, together with the higher academic and social values. The expected result is mental health because according to the system rules, when the mental score is below 13, the student will automatically categorize under mental health. Next test uses a case where a mental score is not below 13 and the academic score is higher than social score. The expected category is academic stress. And then the next section tests the decide risk function. After the system describes the category, it must also determine the risk level, which can be low, medium, or high. The risk threshold depends on the category. For mental health, several sample values are tested, such as a mental score below 8 for high risk, between 8 and 12 for medium risk, and higher mental score for low risk. And finally, is end-to-end wellness workflow. The final section is to test the end-to-end workflow test. This test is important because it does not only test one function in isolation, instead it tests the complete sequence used in the actual system. The second part verifies whether the system can properly manage student cases after the wellness category has been determined. It focuses on 3 main workflows: assigning the case to correct support person, updating the status of a case, and controlling who is allowed to create or edit questionnaires question. So the first function in this section is assign support user. The function assigns a student case to correct support person depending on the support unit. So there are 3 possible support unit tested, which can be academic advisor, school counselor, or CS society. So for the first test, the input simulates a student who has an advisor ID. For example, advisor ID is 50, and since the advisor ID exists, the expected result is the system will assign the academic cases of the student to their academic advisor. And then the next group of tests is for update status function. This function is responsible for updating the progress of the student support case. For the valid update test, the input uses a case with status pending and then updates it into in progress with remarks such as reviewed and contacted student. The expected result is that the case status is updated, remarks are stored, and the response timestamp is recorded. So the final section is the authorization for question management. This is to ensure that only authorized user can create or edit questionnaire question. The first test checks the store action. If a user has no allowed category, then the expected result is 403 unauthorized. The next test checks the successful store case where the user does have valid category, for example, academic. In that case, the system should allow the question to be added successfully, then update authorization is tested. For example, if a user belongs to academic category but tries to update a mental health category question, the system should reject and the action with 403 forbidden. As I run this command, we can see that all of these tests have passed for this part too.